problem could take a lot of time, so make sure you participate in a full-fledged manner and complete the problem within the speculated time. Okay. Okay. Shall we start the problem? Yes. Okay. So in this particular problem, he says it's a pair of Spur gear. So which gear he has given? He has given the Spur gear for us. Okay. So this is the Spur gear. Okay. So first thing he has given is the Spur gear. So just write it down, whatever is the given data. So I would just write it here.
So
Given
questions.
Data. Okay, still you need the question. Make sure you copy it fast, guys. So power is being given. So power is 20 kilowatts. Okay. Shaft rotating at 1000 RPM to a parallel shaft which is rotating at 310 RPM. So two shafts he has given, that means the value of N1 he has given as 1000 RPM, and similarly the value of N2 he has given as 310 RPM. Next, the number of teeth on the pinion is, so that means N2. Okay, there is a gear and there is a pinion, isn't it? So I would take this as 1 and this as 2. It's up to you how you take it. Okay, so N1 is 1000 RPM, and whereas N2 is 310 RPM. And similarly, number of teeth on the pinion, he says, no. So that is Z2. Not getting the calendar link. Okay. What we will do, N1 he has taken as 1000 and N2 he has given as 310 and Z1 he has given as 31. So pinion is 1. So there is a small pinion which I'll be taking it as 1, and there is a big gear which I'll be taking it as 2. Okay. This is the thing which he has given. Next, what he has specified this particular thing, kindly look into it. He has told that it is 20 degree full depth involute tooth form. So this particular sentence he has specified for us. 20-degree full depth involute tooth form. Okay. Next, the material of the pinion is steel SAE 1040 untreated with allowable stress of 206.81. That means he has given the value of sigma D 1, which is equal to 206.81 megapascal. Okay. I think even he has given the value of sigma 2 also. And the material for the gear is cast steel with 0.2% carbon untreated with allowable static stress of how much? It is 137.34. So what I will do is I'll just shift this and make a space. So this is all the pinions parameters. Now the gear one. Okay, sigma D2. He has specified it as how much? 137.34 megapascal. Fine. Next. So this is the given data. And what we need to find, I'll just write it here. So to find, okay, to find, number one, what we need to find, module is being questioned, face width, capital B is being questioned, and the last one, dynamic tooth load. So dynamic tooth load in the sense it is FD, which is also being questioned. So all these three has to question, and at the last he has given the service factor. The service factor as 1.5. So CS is a service factor. He has mentioned it as 1.5. So all these are the given data. Okay. Now we will move with the solution. Okay. So it's better since N1 and N2 is given in the problem. Okay. It's better that I calculate the value of I, right? So what is I? I is nothing but it is N1 by N2. So that is equal to 1000 divided by 310. So what is the value of I, guys? What is the value of I? Please help me with the values so that we can finish the problem fast. It takes a lot of time. This problem is lengthy. Okay.
3.23.
Okay, it's 3.23. And it's very interesting also. So make sure you concentrate well. So 3.23 is the value. Next, let us go for the solution now. Okay, since Z1 is known, you can calculate the value of Z2, is it? So Z2 is equal to I times of Z1. So that is equal to I is 3.23 into Z1 is 31. So what is Z2 then?
Hundred.
100.
100.13.
Okay, you can just make it a round figure because it's a tooth number, no? You cannot make it a random thing or a decimal point since it's a tooth. It cannot be 1.5 tooth. So
100.
that's why we will make it as 100. What's the problem here? Okay. Hundred. Okay. So, what is the first step in a problem? As we have done in the last problem, what is the first step in a problem? In a gear problem, especially. Yes? Anyone?
Finding why.
Identifying the weakest part. So, all of you do it. Identifying the weaker part. So, for that, you make use of the strength factor. Correct? I'll just move this up. So, you'll make use of the strength factor, which is given by sigma d cross the form factor. So, is the form factor expression given in the problem?
No.
So, then you have to look for the data handbook. All of you open your data handbook. And look for the expression. So here you can find on the page number 204. So in this particular thing you can find. So for different types of involute system and different types of pressure angle, so you can find the expression over there. Okay, for 20-degree involute system is the question given, right? What is the given data? So if you observe this, he has mentioned it as 20-degree full depth involute tooth form. For this, what is the expression? Pick that particular expression. Okay. Pick that particular expression there. Okay. So I think this one is the correct one, right? Right? 0.154 minus 0.912 divided by Z. So take that particular expression and write here y is equals to 0.154 minus 0.912 divided by Z, and even write the equation number from which you have taken it as how much? Not this. It is 2.5D, sorry, 12.5D, page number 204. Just write that. Now, you from this you calculate the value of y1 and y2. Okay, and this is for the pinion and for the care. Okay, after that you calculate the value of sigma d y1, sigma d2 and y2. Okay, compare these two values and identify the weaker section, everyone. I think you know the value of z1 and z2, right? Identify the weaker part, everyone. Give me the values of sigma d1 cross y1 and sigma d2 cross y2. Be fast with your calculations. Good, Tanush. So 19.76 and 15.9. 19.76 is for which one? Whether it is 1 or 2. 1. So 19.76 is for the 1. And 15.9. Just check the values. $25.76 for 1, 19.829 for 2. So are the values wrong? Oh shit. So we take this value 25.76 and 19.89 megapascal. So if you get the same value which is written on the screen, you just raise your hands. I want everyone to solve this problem. Okay. Okay. Tanush, so which value is correct? The value which you gave and the value which is here. Okay. So shall we fix on this? So according to you, which one is a weaker part? Yes. Which one is a weaker part? Which one is a lower value? Gear is a lower value. So I would decide upon the gear as a weaker part. So the design would be based on the gear. So that is the conclusion what you have drawn. Shall we move further fast? Next one is to find the module, the first question. Okay. Use the same formula which you have used yesterday. Okay. Module. You can use the same formula. M is equal to cube the root of 2 times of mt divided by sigma d cv k y and z. Can use the same formula which is taken from equation 12.5b in page number 204. Okay. So power is given, so you can use this. Pi is equal, P is equals to 2 pi n2 mt divided by 60. It is nothing but 2 pi nt by 60. From this, substitute the value of power and calculate the value of mt, everyone. So whatever you get the value, you will get it in Newton mm. Okay, you know the value of N2, you know the value of P, thereby you can calculate the value of MT, which is torque. Do it fast. And next, since I guess there is no information given regarding the face width, so when there is no information given regarding the face width, I'll just write it in red color. The points which has to be remembered. No info regarding face width. So in that scenario, what you have to do, you have to assume the value of k, which is b by m, to be 10. So this you have to remember. So if there is nothing given in the face width, you have to assume it as 10. Okay, please to remember and highlight in your notes. Okay, next, even since velocity can also be cannot find out. Okay, so you cannot calculate value of v. So even assuming CV to be 0.5. So even you have to remember this. Okay.
So why is it Newton mm, sir?
So whatever you get the value, that would be in Newton meters. Okay. So change it to Newton mm and give me the value. I want it in Newton mm. Whatever you get the value of, that would be in Newton meters, guys. Okay. Is there any disturbance in the screen and disturbance in the voice? Because I'm connected to my home Wi-Fi, I just want to check that. Is everything clear?
Yes, sir.
Good. So MT in terms of Newton mm, it is how much? 6.616.08. Okay. Into 10 to the power of 3. So this is a Newton mm. So MT is done. Next, I think sigma D. So design is based on gear, is it? So 2. Sigma D2, you know it. Okay, very good. Next is CV, you have assumed it as 0.5. K, you have assumed it as 10. What else? Z2, you know, Z2 is 100. And Y. So Y you can calculate. What is Y, by the way? What is Y? It is pi times of small y. Now the design is based on gear, so it is 2. Okay, so it should be y2. You have calculated, I guess. So just you can get the value from there. So substitute all in equation number 12.5b, and at last give me the value of module, whatever you have got in terms of mm. Any difficulty in this, you can just contact me. Okay, you can switch on your mic and speak. Make it fast, guys. Only calculating module, if you take so much long, the problem is still more for the it has a lot of other stuff to do, so make sure you do it very fast. Okay. Hope everyone have received the Google Classroom. I have just posted the recorded video over there. Have you checked it? Anyone? 15.82 ಅಷ್ಟೊಂದು ಬರುತ್ತಾ ಮಾಡ್ಯೂಲು 6.5. Okay, just check the value, guys, because here I have the value as 3.4. So the value I've given in the textbook is 3.4. Just check. Correct? So 3.4. Now 3.4, once you have got this, okay, now where you need to standardize this particular thing using table number. Okay, standardizing using table number, how much? 12.2, page number 229. Give me the standardized value. Always go with first preference. Don't go with the choice. Okay. If you can go for the choice, it's up to you how you take it. Okay. Standardize this particular value. Go for the data handbook. I have to scroll down, guys. So make sure you go to that particular page number 229. There you can find the table which I've already taught you. Just give me the standard value, which is close to 3.4. That is in the first preferred, right? In the choice, to have the closer value. Let me look into the table, guys. What is the page number? 229. Okay, so this is the table. Okay. Now, where is 3.4 is the value, right? 3.4. In the choice 2, you have a much closer value. 4 is pretty much large. Either of the values you can take. See, there is no problem if you take 3.5, or it is no problem if you take 4. Ultimately, you have to check. You have to check for the load. Okay, after this, you'll be checking for the load. If whatever module you have selected, if it is sustaining the required load, then it is correct. No issue. Okay. But whatever the module, if you have selected, if it is not sustaining the load, then what you have to do, you have to increase the module. Suppose if you have taken 3.5 now, if it is not sustaining the load, how to check it, I will be just explaining after this. Okay. If it is not sustaining the load, then what you have to do, you have to increase it to 4 or 5, like that. Okay. So what we will do, whether we shall take 4 or 3.5. Yes, guys. All of us will take one value and check for the stress. Which we shall take? We shall take 3.5 or 4. Okay, 3.5. Fine. We shall check for 3.5 now. Okay. So standardizing value was 3.5. So I would name this checking procedure as trial 1. Okay. Before that, calculate some of the parameters. For example, PCD of pinion, which is given by D1 is equals to M times of Z1. you have just standardized the value, obtained the value of module, so calculate that. Similarly, PCD of GAR, calculate it, which is T2, which is given by m times of Z2, give me the value, and even the phase width. Okay, phase width B is equals to 10 times of m. This is assumed value, so give me the values. Give me the value. ಅಮ್ಮ ಸ್ವಲ್ಪ ಎಕ್ಸಾಸ್ಟ್ ಫ್ಯಾನ್ ಹಾಕು. How much it is? 108.5. This is the first value, PCD of pinion. 108.5, 350. Sorry. 350 and 35. Okay, now you just write a sentence there. Since CV was assumed, isn't it? CV was assumed, checking for sigma D2. Checking for sigma D2. Now, you will get this particular expression from the data handbook, which says Ft is equals to pi sigma D CV B small y m. Okay. So give me the equation number from where you will get it. The data handbook. It is 12.5a. 12.5a, page number 204 again. Okay, from this you'll get this particular expression. Now calculate the value of V, guys, whether it is based on GAR or pinion. It is based on GAR, is it? So just take pi D2 N2 divided by 60. So that is equals to pi D2 is 350 cross 310. Okay, divided by 60. What is the value? Okay, so much. Okay. Diameter is 350 mm, right? So we have to substitute that in meters. So 350 into 10 to the power of minus 3. Now what is the value? .68 I can take. Am I right? Sorry. Okay, good. So 5.68. Now, is there any expression for CV which is given? Yes. So is there any expression for CV which is given in the problem? I guess it has not been given. So go to your data and again I have to scroll. Go to the data handbook. On that page number 205, I guess, there you can find the equations V. Per second. So up to 8 meters per second, Pat's formula has been given. What is the velocity you have? Yes, exactly. 12.6a. Pick that particular equation, which is this, because it is less than 8 meters per second. Pick that particular expression. And write it here. CV is equals to how much? It is 3.05 divided by 3.05 plus V. So you have the value of V there, just calculate it. So give me the value of CV. 0.34. Okay. 0.34. One more digit, 349. Okay, I can approximately take it as 0.35, or else I can leave it as such. Now, you know about the value of FT, correct? So what is FT, guys? FT is a tangential load, isn't it? Okay, FT is a tangential load. Now, so torque, there is a concept known as a torque, correct? So torque is nothing but it is force into the perpendicular distance, correct? Do you know about this? So now here the torque is m to the suffix t. Force to the force is nothing but the tangential force cross the perpendicular distance is d by 2. So from this, I can calculate the value of Ft, that is equals to 2 times of mt divided by d. Remember, this is d2 because you are considering gear. And also remember, you have to multiply this by CS. So just mark this. So just write remember. Okay. So while calculating the load, you have to multiply it by the service factor. Is the service factor given in the problem?
Yes.
So just take that value, calculate it, and give me fast what is the value of Ft. So Ft finally, it accounts as 2 times of mt divided by d2 cross cs. So from this, what is the value of Ft you would get? Okay, 520, sorry, 5,280, 5,280.7. Just check the value. Is that correct? So if this particular value is correct, very good. So now what you have to do, take this expression again, which is this. Okay, take this expression. In this particular expression, you know that you know the value of Ft. Very good. Pi is a constant. Sigma d you have to calculate, guys. Sigma d of 2 you have to calculate. Cross Cv you have just calculated. B you know, Y you know, and even the M you know. So the only change that would happen is sigma d2. So here you calculate the value of sigma d2 from this. So this is the
Sir,
actual
this is the
stress.
checking process, sir.
So we are in the checking process, Ruben. We are this. So whatever we are calculating now is that particular stress value, which is actually happening in the gear. Okay. So whatever the value you have got now in terms of MPa, is the value of stress which is occurring in the material. Okay, and you have one more value which is sigma d2, and this is the allowable value. So what do you mean by allowable value? This is the maximum amount of value of stress that can be allowed in the gas. So that particular value, I guess it is 137.37 megapascal. According to you, or according to everyone, I'm asking you, whatever the value you are calculating here, which is the value, which is the stress which is acting on the thing, it should be less than the allowable value, or it should be more than the allowable value, according to you. The maximum allowable value was 137 for the gas. And this is the amount of stress which you are acting on the gas. Whether this particular stress should be less than the design value or it should be more than the design value. Less, isn't it? So that is what we are checking for. It should be less than the design value. If it is more than the design value, what you have to do, you have to increase the module depending upon how much it is more. Suppose the mark, just give me the value. I will explain after that. Give me the value. Just check whether it is less or more. $285. Oh my God. $289. Oh, 289 is the value which I've got. 190. So which one is the correct, guys? There are multiple values which are coming up. Which one is the correct value? ಇಲ್ಲ ಮಾಡಪ್ಪ ತೊಂದರೆ ಇಲ್ಲ. So which one is the correct value then? 190 or 285 or 289? Make it fast, guys. Are you able to hear me? Okay. So 285 is the left. Shall I take it? If every one of you get the 285, just raise your hands. Let me check. Okay, many people are calculating still. I think there is a single equation, man. No big calculations in that, right? Okay, 285 would just fix upon. 285 megapascal. Okay, now, yes. So now compare these two values now. So the whatever stress is being act on the gear is 285 if you use the module as 3.5. But the maximum allowable stress value for the gear is 137. So if you use a gear which is having a module number 3.5, the stress would increase up to 285, which is totally unsatisfactory. Correct? Am I correct? So that's why write a sentence there. Since calculated value are greater than permissible, or you can even say it as allowable values, which is the values in the sense it is values of stress. Okay. Selecting module 3.5 is unsatisfactory. So if it is unsatisfactory, then what is the next option do you have? What is the next option, guys? Go for the 4? Okay. Just think. It's a common sense. Okay. Just think in a random basis. Because again, you can go for the 4. No issue. Okay. But remember, in the examination, you'll be having very less time for the design because it has a lot of calculations in it. Okay. Understanding and doing the calculation will definitely help you to retain your time. Okay. Why I'm talking all this is just look at the values, guys, here. Okay. ನೋಡ್ರ ಇಲ್ಲೆಷ್ಟಿದೆ 137 ಇದೆ ಕಣ ಅಲೋವೆಬಲ್. ಓಕೆನಾ. ಬಟ್ ನಿನ್ ಸ್ಟ್ರೆಸ್ 3.5 ಹಾಕಿದ್ರೆ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? 285. ಇಟ್ ಇಸ್ ಆಲ್ಮೋಸ್ಟ್ ಡಬಲ್. ಕರೆಕ್ಟಾ? ಆಲ್ಮೋಸ್ಟ್ ಡಬಲ್ ಇದೆ ವ್ಯಾಲ್ಯೂ. ಸೊ ಇಫ್ ಯು ಜಸ್ಟ್ ಇನ್ಕ್ರೀಸ್ ಫ್ರಮ್ 3.5 to 4, okay, this may come down to 285 to may around 200 or 190 or 180, something like that, approximately. But if I go for the still more higher value, which is 5, I guess, right? Still more higher value, which is 5. So if I go ahead, then I can push this still more down, well below the value of 137. That is my assumption. What do you think? Shall we go with 4 and check and then we'll go with 5, or we shall directly go with 5 and check? Try 5. Okay, so I don't know. So in the examination, it's up to your knack and your caliber in how many trials you will come to a exact module. Okay. So just try to solve it. Then it will save the time in the examination. If you do not solve it here, you'll be under trouble. Okay. So now going to the trial number 2, where I am adopting final. Shall we take it 5 or we'll try with 4? 5. 5. Okay. So adopting module is equals to 5. Now, again, kindly repeat the same procedure, which is this, the whole thing, same procedure. All this. First, calculate the PCD of the pinion, calculate the PCD of the gear, calculate the face width. Okay. Then take this particular expression through which you are calculating the value of sigma D. Okay. For that, calculate the V value, then calculate CV value, then calculate FT value, substitute back, calculate the value of sigma D2, and check whether it is less than 137 or not. Will you do it, or should I again solve it on the screen? Will you try? Yes or no, man? Okay. Try. If you are facing any doubt in between, if you're stuck anywhere in between, you can contact me. Okay. Just follow the same procedure and give me the value of design stress, or sorry, give me the value of stress which is acting on the gear, and hope that this particular value is less than this particular value, which is 137. So if it is less than that, you win the game. waiting for your values, guys. Okay. Try to maintain your notes very neatly. Whatever the points I would be stressing upon in the online class, please do write it with a red pen or highlight it with any other means you have, highlighter or use a pencil or draw a circle, because these points will save your problem by going in the wrong way. So if you miss these points, definitely your problem would be a disaster. Okay, so all these points are important. Solving in the class is very, very important. Then only you'll get to know. It is not one day subject. If tomorrow is the examination, if you sit for 3 days previous examinations, also you will not be in a position to cover it, or you will not be in a position to understand it or learn it. So this is a subject of practice. Okay, practice using the data handbook. You have to practice, get to know the things, get to know the concepts. Then only you'll know the subject. So my sincere advice is 1 hour of design class. Please work sincerely. Please solve the problem in the class. Write it in your notes. That is very, very important. Okay. Yes. Completed. I am very much eager to know the design stress, not design stress, the stress which is acting on the cat. Whether it is lower than 137 or higher than 137, because that decides the number of trials. If you get lesser than 137, then it's fine. You can end your trial business here itself and conclude the valid. If it is again greater than 137, you have to go for trial 3 and increase the model to 6, 7, 8, like that. You cannot guess, Nitish. So whatever you have calculated, that would be there, right? So 90.23 is the value given by Nitish Kumar. So it is well below 137. That's a good value. If it is a very good 90.78, 90.78. So I guess that's the correct value, right? Very good, very good. So now, after all these calculations, write a sentence there. Okay. Since calculated values, all of you write it. Since calculated values are less than permissible values are less than permissible values, the assumed values are satisfactory. The assumed values are satisfactory. So, therefore, choosing the module to be 5 mm. Choosing the module to be 5 mm. So all of you have to write the sentence in your notes. Okay. Next. So this is one thing, calculation of the module. So after all this circus, so what is the value that you are fixed upon? What is the value that you are fixed upon? 5, isn't it? So that is the value. Okay. So this is the module calculation. Next, B bit. You have to calculate what? You have to calculate the phase width there, which is denoted by, capital B. How do you do that? It is 10 times the module, which you have assumed, no? So it is 50 mm. So this bit is finished with a single line. Next one. What is the last one that you have to calculate? What is the last one that you have to calculate? FD, I guess. FD. What has been asked there? FD. Correct? FD is nothing but dynamic tooth load. Dynamic tooth load. Now, open your data handbook, search for the formula through which you can calculate the value of FD and give it to me. FD. FD. This is FD there, not FD. Dynamic tooth load. Again, FD. FD, FR, FN. FNU max. I guess here it is, right? All of you got this? FD. All of you got this? I think which page number? 207. Page number 207, you have the formula here. You can take it from here. Okay. And all the parameters is being mentioned clearly there. Okay. Just take that particular formula. It says FD, sorry, FD is equal to FT plus K3 into V. Okay. Next it is what? CB something plus FT again. And this whole divided by K3 into V plus square root, another square root of C cross B into T again. C cross B plus FT again. Now, in this whole big formula, I told you if it is a big formula, just draw a line behind that like that. And what is the value of FT? What is the value of FT? Because I don't know the value. You have calculated in the trial 2. What is the value of FT in the trial 2? Which the trial which you are fixed upon. The trial which you made satisfactory, those values you have to take, remember. Okay, FT is 3696.48 Newton. Very good. Any information regarding K3? So here is given. In SI units, you pick the value, correct? It is how much? 20.67. So pick up the value of K3 is equals to 20. This is just a form. That's more than enough. Next, what else? What else value you need? What else value you need? You need, let me look into the data handbook. Okay, for C, dynamic factor. Again, on ದೊಡ್ಡ ಕೊಟ್ಟಿದ್ದಾನಲ್ಲ. Okay. So C is given as E divided by K1 into 1 plus E1 and 1 plus E2. So what are E1 and E2? E1 and E2 are the modulus of elasticity of pinion and gear materials respectively. Okay. Or else there is a table, some table is given 12.12. Just check there, guys. 12.12. 12.12. 12.12. Okay, in that particular 12.12, error in gears. Yes, given. Okay. 12.14. Okay. Okay, so what you have to do, I will just show you here. Okay. See. Come back to table number 237, page number, come to page number 237, all of you. Okay. So here is the value of C from which you can pick. Okay. So before getting into that, you have to fix upon the error here, isn't it? So error value you must know. This you know, which degree it is 20-degree involute system. Okay. What type of material the gear and the pinion is using, even you know that. Okay. Just read the question for that. Which type of material is being used? Untreated alcoholic SA in the sense that it's steel. Okay, pinion is made up of steel, and this one, untreated alcoholic cast steel. So even the gear is made up of steel and the pinion is made up of steel, correct? Are you following, guys? Are you there? First of all, this is important. Okay, so both the materials are made up of steel. So it is 20-degree full depth involute in that steel and steel. Getting my point? Because gear and as well as the pinion is made up of steel there. In that means you have to fix upon these values. Out of these values, one of the value is your value. Okay, one of the value is your value. For that, you have to decide upon the error in the gear. For that, you come back to page number, next page, which is table number 12.14. Okay, 12.14. In this, with the velocity, you can choose the error. Okay. So what is your velocity? How much is the velocity of the gear? 8.11. So approximately I can take it as 8. So I can choose upon the error as how much? 0.05 mm error. Okay. Now if you come back to this particular table, 5.05 mm is the error. Come back to this particular table. Okay. Now, so steel 20-degree involute system in that steel. So this particular column is there. Now here you have to choose a value. Okay, between these two. Okay, 0.04 is there and 0.06 is there. So which one will you take? Take for 0.04, the value is how much? 457.8. For 0.05, sorry, 0.5 is not there, 0.6, the value is how much? The value is 686.7. Now I need the value which is at 0.05. How do I do that? Any mathematics experts here? Simple mathematics here. You should not go for the higher value, guys. You have to take it for 0.05 itself. Okay. So how do I do it? For 0.04, it is this one, 457.8, and 0.06, it is 686.7. I need the value for 0.05. Yes, what is the formula? What is the formula? That is I'm asking you. Average, how do you do average? If you do average, how much it comes? What is the value of average? So, sir, HT class at 11:30. Oh, sorry. I'm extremely sorry. You could have said me no. You could have said me. I'm extremely sorry for that. Okay. Okay. So now you decide upon the problem is being struck here. We will leave it here. Okay. I need the value for 0.05. So how to calculate the value for 0.05 while I have the value for 0.04 and 0.06. So think upon it and come up with a solution in the next class. I guess if the value of C is decided upon, all the values you already know except C, so you can calculate your value of FT, that completes the problem straight away. So if you get this particular solution for this, your problem will be completed. Okay, so we'll meet up in the next class. Before to that, kindly mark your attendance in the sheet which I have provided. Okay, I would say to Swarup sir to take 5 or 10 minutes after this. Okay, don't worry. Till then, take care, guys. We will meet up in the next class. Have a nice time ahead.
Attendance.
Attendance, that's what. Mark it in the Google sheet which I have provided. Kindly remind me from the next class, guys. If it is of 3 minutes, 4 minutes before the end of the class, kindly remind me, because these design problems definitely takes 1 hour greater than what we expect. Okay, so definitely takes a lot of time. So make sure you remind me. Okay. Shall I end the call?
Yes, sir.
Okay.